but x has some, there's some initial conditions associated with what's going on here. And so you have the initial conditions along with the filter, and that's and the initial conditions are based on B, A, and the values of Y, because the initial conditions get messed around, and when you finally get them, they show up as, well, we never did it there. They show up as this, do I have that right? Mm-hmm. I did that, and I did that. 0.05, 0.25, plus 1. I didn't write this right. I didn't write this out right. There's a piece missing. 5 plus 0.5. I left out there. There's two 0.5s there. So anyhow, this turns out to be 1. So this is the initial condition for the filter. All right. 1 and 0.25, because that's there's no denominator. The denominator doesn't exist there. So those result from application of these initial conditions into this equation here, because when you transform these things is where those initial conditions show up, and they get processed by the coefficients that are involved, and when you reduces and it comes out here, the ones that don't have any denominator, there's no denominator associated with it, those are result of the initial conditions, and those things have the same value as this thing right here. Okay? So YIC is equal to 1.25. So if you want to do this the long way, you got to do it this way and figure out it's 1.25. If you want MATLAB to do it, you just do this. You put B, A, and you put Y, you put the initial conditions, and it figures out these two coefficients for you automatically. But anyhow, no matter how that's determined, then you can use the filter function with the input x, which you have up there, plus the initial conditions that result. And you'll get that. And then, we did that. You did that. And so now this generates, this y is different than this y down here. This is y. Well, that's y. This is y, and it's written as y of n because it's a function of n. So now you get y. This is a bunch of samples. That's 21 samples. Right? Then you use this equation down here to generate, well, y prime for 21 samples. Okay, and you can use that equation. And there's a fancier ways to write that equation. You can use the residues and combine them in a loop and have a loop do the computation for you. But it doesn't make any difference. You get that expression, and that generates y prime. And y prime ought to be the same. So how do you tell if they're the same? Well, you generate something called an error, and you take the max value of the absolute value of y prime minus y, or any other way around. And that typically comes out to be something very nearly 0, because they're going to be the same. Because they're not going to be any different. Okay? What's that? Well, what are you talking about?
Or the absolute.
Yeah, the error is the maximum value or the absolute value of the difference. It's like a double whammy here. All right? This is the absolute value, and this is the max function.
Y prime minus Y.
Yeah, you want to take the difference of the two expressions. And you can plot them, you can plot y and y prime and they'll look the same. But if you want to be a little more direct, you can generate that error, which is the absolute value of the maximum of the absolute value of the difference. And they're so close together, that number is very, 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 very small. Call it 0. It's like 10 to the minus 15th or something. Okay? Okay, so that's the expression of the solutions, okay, that use MATLAB to aid in the development of the solution. So it's a combination of using stuff written out and solving it a little bit that way, and where applicable, you involve MATLAB to do some of the calculation for you. You don't have it. So you can't do it all by MATLAB because MATLAB can't do algebra very well. So you have to do the algebra, but when it comes down to doing simplifications or combinations or finding residues and all that stuff, MATLAB helps out a lot, or plotting, and MATLAB's a big help. And so you want to use MATLAB in those cases, right? So now it comes down to, okay, you have the idea of, I mean, it shouldn't take very long here. So now you want to do you want to use MATLAB, right? For some of this stuff. So you got to go over here with MATLAB. MATLAB over here. MATLAB is over there. We don't need that. We don't need that. We don't need that. Put a big white palette up here. File. Here, here, that goes over there, over here, over here, over here, and so you know you start out with. What do we have? This is a sign. This is you know P. Johnson. Assignment number 5. And oops, right there, right? And this is 7 April 2014. So all you document the stuff, so you know who did it when it was done. And now you can do. Then another thing you want to do is you want to do format. You want to complement or leave a blank space. I guess you can do whatever you want to there. You can do something fancy. I don't know. You go up here, do something fancy. People love to do this kind of stuff. But anyhow, so now you want to format compact. Okay.